Hi everyone. So this next section is called coordinate tests, or that's what I call it anyway. And basically, what it is you're given the coordinates of a quadrilateral. So this is the example that I'm going to be doing while I'm doing these. So like these notes, it's kind of just like directions on how to do it. There's no example that goes with it because you kind of have to go back and forth between like these and the examples. So I'm just going to do my example on another sheet of paper. So if I were you, I would take a minute, write down this example and follow along with me. And so, like I was saying, you're given the coordinates on the coordinate plane of a quadrilateral, four-sided figure, and you're asked to classify it. Is it a simple quadrilateral? That just means like it doesn't have any of the properties of a parallelogram, rectangle, rhombus, or square. It's just like a random four-sided figure. Is it a parallelogram? Is it a rectangle? Is it a rhombus? Is it a square? Now, when you're doing this, you can plot it on the coordinate plane if you'd like. I honestly don't usually, just because the way you have to prove it is you have to do out all this work I'm about to show you. It's we use different formulas that we've used, well, this year, and then the one that you probably learned last year or maybe the year before. Anyway, so either way, whether you plot it on the coordinate plane and you're like, oh, that's a square, you still have to show out all the work. So I personally don't bother plotting it on the coordinate plane. You can choose to do what you want. If you want to plot it so you actually like know going in what it should end up being, that's fine. I don't do it that way. So we have our ordered pairs. Here are the directions here that we're going to follow. The very first thing that you do, whether you do it on the coordinate plane or not, you do have to sketch a figure. Now, the reason why I tell you to sketch a figure is so you know where the vertices are. Now, when you have a quadrilateral, it's important when you label them that you label it around the figure and you don't like jump around. So I'm just going to draw just a small like quadrilateral over here. I know I'm making it look like a parallelogram, but I don't know what it is. So if I'm starting here with A and then B here, I have to go C here. I can't jump and put C over there. Okay, so just so you get an idea of where the different vertices are, so you know like what the sides would be, what the diagonals would be, and so on. Okay, once you do that, the first thing that you test for is to see if the shape is a parallelogram. Testing to see if it's a parallelogram will kind of let you know if it's a rectangle, rhombus, or square, right? Because rectangles, rhombi, and squares are all types of parallelograms. So if you get that no, it's not a parallelogram, then it can't be a rectangle, rhombus, or square. So you're kind of done as long as you're absolutely sure that your work is correct. Because most of the ones we're going to do are parallelograms. There might be one on your practice that's not, but all the rest should be. So to determine if it's parallelogram, there's a lot of different ways you can do it. Here's 4 options that you can choose. You only choose one of them. You do not do all of them. This one down here with the stars, this is the easiest one. So you may be wondering, well, why is she bothering to show us the rest? Well, every year I show these options to kids, and inevitably there's always a couple of kids that like one of these methods better and use it on a test. And it might be just because those are the formulas they remember, but either way. Okay, so let's just go through these. I'm still going to go through all the options, but when I do out the example, I'm only going to do it with part D. Okay, so the first thing that you can test for is you can test to see if the opposite sides are congruent. Because we learned that both pairs of opposite sides are congruent in a parallelogram, right? So to do that, you would use the distance formula to test if both pairs of opposite sides are congruent. So that would require you to do 4 distance formulas. I would have to plug in A and B. I'd plug in D and C. I'd plug in A and D. I'd plug in B and C. You would need all 4 sides. That's a lot of work. I don't want to do 4 distance formulas. So that's why I don't choose the first one, because it's more work. The next one is opposite sides are parallel. So that's another way you can show if the shape is a parallelogram. You can check to see that both pairs of opposite sides are parallel. You may remember learning about slopes of parallel lines back in probably middle school, but that's what you would use. You would use the slope formula. Parallel lines have the same slope. So that's what you would be looking for. The slope formula is this, y2 minus y1 over x2 minus x1. So that's m. Remember how m is slope? So what you would do here is you would look at the figure. You would find the slope of AB, the slope of DC, the slope of AD, the slope of BC, and you'd compare them. Are these the same slope? Are these the same slope? If it's a yes, then yes, it's a parallelogram. Slightly easier formula, but still, that's 4 things I'd have to be calculating, and I'm not trying to do 4 things just to see if it's a parallelogram. So I don't do that one either. Part C, another way you can test to see if it's a parallelogram is you can test that one pair of opposite sides is congruent and parallel. So you choose one pair of opposite sides, and you would use the distance formula and the slope formula. It's kind of like a combination of A and B. So what you would do for this one, you would either choose these two, find how long they are, find the slope of them. If they're both the same, the length and the slope, then it's a yes. Or you would do these two, find out how long they are, find the slope of them. If they're both the same, then yes. That's still 4 things to calculate, 2 distances and 2 slopes, which again, I'd rather not do. So here's the last one that I think is the easiest. The last one is you can test to see if the diagonals bisect each other. If the diagonals bisect each other, remember that means they cut each other in half. That's one of the properties of a parallelogram. For this one, we're going to use the midpoint formula to test if the diagonals bisect each other. They have to have the same midpoints. So for this, we have to use the diagonals. So let's go back to our picture. These are the diagonals, DB and AC. Now wait, let me come back over here real quick. Let me write the midpoint formula for you in case you forgot. So the midpoint formula is in parentheses x1 plus x2 over 2, comma, y1 plus y2 over 2. That's the midpoint formula. So you would do that with the 2 diagonals, and if you get them, them to be the same, then yes, it's a parallelogram. So I'm going to do this right now with this example. Sorry that was so blurry. I just realized I just focused it a little bit much more clear. Okay, so let me zoom out a little. When you organize your work, super, super important for yourself so you can just stay organized. And for me, when I eventually am going to have to grade something of yours where you're doing a problem like this, please, for my sake, organize your work so I can follow it. So by organize your work, I'm like, okay, the first test is parallelogram test. So let's label this work I'm about to write parallelogram test. And rather than just randomly starting to write numbers, let's write down what I'm actually going to find. I'm going to find the midpoint of AC and the midpoint of DB. So where I'm about to do my AC work, I'm going to write AC. I'm actually going to go as far as writing out the ordered pairs. I mean, you don't necessarily have to go this far, but there's A, there's C, and I'm going to plug that into the midpoint formula. So I'm going to label x1, y1, x2, y2. Let me zoom in a little bit so you can see better. So midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2, comma. Parentheses. Whoops. So then you do the tops. So -1 plus 11 is 10. 10 divided by 2 is 5. -5 plus 13 is 8. 8 divided by 2 is 4. So the midpoint of AC is 5, 4. Now I'm going to do the midpoint of BD and see if it's the same. If it is, then yes, it is a parallelogram. So let me zoom out a little bit. I'll do BD right here. So B is 8, 2. D is 2, 6. X1, Y1, X2, Y2. We'll plug it in. So X1 is 8 plus X2 is 2 over 2. Y1 is 2 plus Y2 is 6 over 2. So 10 over 2 is 5. 8 over 2 is 4. So see how those are the same? So that would mean that, yes, it is a parallelogram. So we're going to see if these are the same. So, yes, it is a parallelogram. There's the first test. Once you determine that it's a parallelogram, you can then test to see if it's a rectangle or a rhombus. Sorry. I always do rectangle next. No particular reason. I don't know why. I just always did rectangle next. So the rectangle test, there are a few different options for rectangle, but I didn't want to spend all night going over every single possibility. So I'm just going to do the one that is easiest. And to see if it's a rectangle, remember that a rectangle is a type of parallelogram. So think about the things that differentiate between a rectangle and a parallelogram. One would be the diagonals are congruent. Another would be that the sides are perpendicular. So you could do the slope and see if they're negative reciprocals of each other. That would be an option, but this is the easiest one. So we're going to use the distance formula to find the length of the diagonals to see if they're the same. This is the distance formula in case you forgot it. X2 minus x1 squared plus y2 minus y1 squared. Okay, so now I'm going to switch over to the other paper and I'm going to do the rectangle test. Now, since I'm using the diagonals the whole time, AC and BD, I don't have to rewrite A and C and label them. I'm just going to write like AC like this, and I'm going to use these labels to plug into my distance formula. So it's x2 minus x1, so 11 minus negative 1 squared, plus y2, 13 minus y1, 13 minus negative 5 squared. Okay, so that's 11 minus negative 1, which is plus 1. So it's going to be 12 squared. And then 13 minus negative 5 is going to be 18 squared. So let's do that. So we're going to have 144. And then 18 squared is 324. So 324 plus 144 is 468. And really, I don't even need to see. Oops, sorry, I just realized you can't see. I don't even really need to take the square root of 468 if I don't want to, because really I'm just comparing it to the other one. So it doesn't really matter what the decimal is, but just in case you guys care, the square root of 468 is about 21.63. So you can leave it like this, or you can get the decimal. It doesn't matter. We're just going to compare this now to the other one. That's all. Okay, so now I'm going to do BD. And again, I already wrote out B and D up here, so I'm just going to reuse those labels. So it's x2 minus x1, so it's going to be 2 minus 8 squared plus 6 minus 2 squared. So 2 minus 8 is negative 6. 6 minus 2 is 4. So I can already tell this one's not going to be a rectangle, but that's okay. So let's keep going. So negative 6 squared is 36 plus 16. It's going to be 52. So see how the square root of 52 is obviously not going to be the same as the square root of 468. I will still figure out the square root of 52 though, just for you guys, about 7.21. So since these are not the same, the diagonals are not congruent. So not the same. So we're going to say no, not a rectangle. Okay, so not a rectangle, but it could still be a rhombus. So we're going to do the last test, which is on here as the square or rhombus test. Now I put square or rhombus because if we had gotten yes for rectangle, then right now, yes, we'd be checking to see if it's a rhombus, but really if it's a rhombus, then that means it's a square, because remember, square is all of them. Remember we talked about how a square is a rhombus, rectangle, and parallelogram. So if I got yes, 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 that's always a square. We'll talk about all those options after. So right now, it's technically the rhombus test. So really I could get rid of square or rhombus. It's technically the rhombus test. So to see if it's a rhombus, we're going to use the diagonals again. We're going to see if the diagonals are perpendicular, because that's something about a rhombus that differentiates between like a parallelogram and a rhombus, is that the diagonals are perpendicular. So for that, we're going to use the slope formula. to see if the diagonals are perpendicular. Now let's think about, how do we know lines are perpendicular on the coordinate plane? You may remember from middle school, or I honestly don't know when you learned this anymore, but slopes of parallel lines, we already said at the beginning, parallel lines have the same slope. Perpendicular lines, you might remember, their slopes are negative reciprocals of each other. So slopes are negative reciprocals. Sometimes you may have learned that as opposite reciprocals. So first of all, what's a reciprocal? A reciprocal is when you have a fraction and you flip it. Negative means you change the sign. So change the sign and flip it. And so here's some examples of negative reciprocals. Say I had -1/2 for one slope, and the negative reciprocal of -1/2. If I flip this and change the sign, I get 2. So that's one example of negative reciprocals. Sometimes you may have to reduce your slopes in order to compare them. Like say, for example, I had 6/8 and -4/3. You might look at that initially and be like, oh, those are not negative reciprocals. But really, 6/8 is the same as 3/4. So 3/4 and -4/3, that would be a yes. These are negative reciprocals. So always make sure when you're doing the slope formula that you reduce your slopes. Super important. Here's the slope formula in case you need it. I know I wrote it up ahead, but that's what we're going to use. So now I'm going to come back to my example, and I'm going to do the rhombus test. Okay, so for AC, remember that it's y2 minus y1. So again, I'm using this up here, y2 minus y1, 13 minus -5 over x2 minus x1. So 11 minus -1. So minus and negative changes to positive. So 13 plus 5 is 18. 11 plus 1 is 12. And we can reduce that, right? 18 over 12, we divide both by 6. It's going to be 3/2. So now if I do the slope of BD, and it's -2/3, then yes, it is a rhombus. So let's see what we get. So it's y2 minus y1. Again, I'm using these. So 6 minus 2. And then 2 minus 8. So it's going to be 4 over -6. Oh, will you look at that? -2/3. So these are negative reciprocals. Do we see that? If we flip this one, change the sign, we get this one. So that means that, yes, it is a rhombus. Okay, so let's think about what our final conclusion would be. I know this seems like it took a really long time. It's just because I'm stopping and explaining. But when you do it yourself, yeah, there's slightly longer problems, but nothing that you guys can't handle. Easy math anyway. Okay, so we got, yes, it is a parallelogram. It's not a rectangle though, but yes, it was a rhombus. So overall, your final conclusion would be that ABCD is a rhombus. It's kind of repetitive to say that it's a rhombus and a parallelogram. Like you saying that it's a rhombus kind of covers the fact that it's a parallelogram, so you don't need to say it's a rhombus and a parallelogram. So that's how you would do a problem like this. Real quick, I just want to kind of recap with the different combinations that you could get, because usually when I teach this in class, kids always ask well, what if it was this, whatever. So on the back of this paper, I am going to make a little chart. So we have the parallelogram test, we have the rectangle test, we have the rhombus test. So one second, I gotta close my door. Okay, so if you get that, yes, it is a parallelogram. Let's go with all yeses. Yes, it is a rectangle. yes, it is a rhombus. Your final conclusion would be that it's a square, right? Because a square is a parallelogram, rectangle, and rhombus. So that would be a square. What else could we get? What if we got, yes, it's a parallelogram. Yes, it's a rectangle. No, not a rhombus. That would be a rectangle, right? Sorry, let me zoom in on this a little bit. I don't know why I'm so far away. What if we got, yes, it's a parallelogram. No, it's not a rectangle. Yes, it's a rhombus. That's the one we just had. That would be a rhombus. Add some more to this. Let's say we got, yes, it's a parallelogram. No, it's not a rectangle. No, it's not a rhombus. That would just be a parallelogram. And lastly, which this doesn't happen very often, but if we got no, 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 let's think what that would be. None of them. So we call that a simple quadrilateral. Okay. So those are your different possibilities. And there's actually one more thing that I needed to talk about, and it's slopes that are zero and undefined. So real quick, I know this video is already kind of long, but you're going to need this for when you do the rhombus test. So I'm just going to add this in. This is not related to this, so let me do it somewhere else. Hold on. Okay, so I'm going to do it here. So undefined in zero slope, we'll call it. So you may remember from Algebra 1 or pre-algebra that a slope that's undefined, slope of a line that's undefined, an undefined slope is a vertical line. A line that has a slope of 0 is a horizontal line. Now, any vertical line is going to be perpendicular to a horizontal line, right? No matter what. So how this looks algebraically is, you may remember, a slope that has an undefined, has a 0 in the denominator. So 0, whoops, in denominator. Remember, you can't divide by 0 in math. So for example, if I got like, I don't know, 10 over 0, this would be an undefined slope. So that's undefined. A slope that's 0 is a 0 in the numerator. Why do I keep forgetting the Z? 0 in numerator. Okay, so for an example for that would be like 0 over 10. That'd be 0. So even though 10 over 0 and 0 over 10, even though they're technically not negative reciprocals of each other because they're both positive, they would still be considered perpendicular. Because anytime you have a slope that's undefined and anytime you have one that's 0, they're automatically perpendicular because every vertical line and every horizontal line are always going to be perpendicular. So I wanted to go over that because I'm pretty sure that comes up in your practice. So hopefully that's helpful. That's it. If you have questions about anything, feel free to reach out and I'm more than happy to help. All right. Have a nice day.